Let's review all of this with this factors. So beginning with distance time graph. So along the x-axis and the y-axis, what goes? Under distance time graph, along the x and y-axis, what goes? Along the y, we have the distance that we will be writing. Actually, let me use another color. Something like this. This is a distance and this would be time. Right? So let's have a look actually, so that we don't just assume and not understand, and there's a doubt in your mind. I don't want that to happen. So let's have a look. So this is a distance time graph. Along the distance you have, along the y-axis we have the distance, and x we have the time. The slope of a distance time graph gives us, yes, speed. That is, see, slope of any graph is nothing but it's a division between change along y divided by change along x. So this is change along y divided by change along x. So change along y is your distance and x is your time, and that will give us speed. Area under the graph is nothing but change along y into change along x. It's a product between these two. But yeah, multiplying distance and time will not give us anything. Next thing is displacement time graph. In displacement time graph, we have displacement along y, and along x we have the time. This is a displacement and that's time, and the division, right, we are dividing this two, is it not? Y divided by x is nothing but your slope, will give us velocity, and the product of this two is nothing. Next is speed time graph. So along the y we have the speed, and along x we have the time. The slope of speed and time for a particular condition, it's acceleration, not all the condition. And the product of speed and time, what does it give? Till here it has been repetitive. Now we are looking at area under the graph. So what does the product of speed and time give? Quite simple, distance. So with this very formula, with the first in a row, we can find that yes, with speed and time we can get distance. By knowing distance and time we can find speed. By knowing speed and time we can get distance. That's it. Next thing is velocity time graph. Along the y we have the velocity, and this is time. The slope of velocity time graph, yes, this gives us acceleration under all condition. Here there is condition applied, right? So we have velocity time graph. Here we are looking at velocity along the y-axis and time along the x-axis. So the ratio between these two will give us acceleration, and area under the graph will give us simple displacement. Now acceleration time graph. Along the y we have acceleration, and x we have the time. The slope of acceleration by time will not give us anything. We will not define anything. And area under the graph, that is the product of acceleration and time, what does it give? Velocity. Right? Similar to how we spoke about velocity by time is equal to acceleration. On a similar manner, by relating acceleration and time, we can get velocity. So it's similar to the above pattern, to be frank. That's what I meant to say actually. Distance time graph gives us speed, and speed and time gives us distance. Velocity time gives us acceleration, and acceleration time gives us velocity. Of course, here we're looking at product, here looking at ratio. You just think all of this is nothing but a formula being rearranged. right? Of course, before that we need to understand the concept, because everything is very clear over here and it's very practical and physical also. That is, you get to see this when you're traveling, or you just go see a vehicle, you will be able to talk about everything about that motion of that particular object in all of these terms. It's very simple, right? I hope this review helped you guys get a good picture about what and all that we have learned and how they are related. So next step would be to see them in terms of formula and apply it and so on and so forth. Derive it, apply it. So put everything together. So next is the advanced version, because we are going to come across all of these factors put together.